All right, so we have talked about so many different functions already. We've talked about linear, we talked about quadratic, we talked about cubic, we talked about step functions, floor functions, we talked about all the different types of functions that are out there, piecewise functions. We just finished that part. And now we get to talk about this wonderful, wonderful, amazing type of function, which is called the rational function. It looks weird because it has a fraction and everything, but it's wonderful and it's nice and it has these little weird looking shapes and everything. But it's going to be great. So here we're going to be doing graphs of rational functions. So we're going to start off with some information here, and then we're going to examples and all the great stuff, and it's going to be wonderful. It's so great. It's going to be so great. All right, so first off, we're going to talk about what the actual rational function looks like. All right, so first, with what we've talked about already in the past, when we looked at all of our parent functions, the important parent functions, the last parent function that we talked about was the rational function. So with that, or one of the last ones we talked about was the rational function. With that, we know that the function actually has the graph that looks like this. But then there was also some other parts that we put in that look like this. And we didn't really explain what was going on. We just kind of said, okay, this is the actual function. So now we actually need to go ahead and look at it and go from there. So with that, when we looked at it, we were like, okay, we have these red dotted lines, these dotted lines right here. With that, this rational function actually has a thing called asymptotes. Oh, asymptotes. All right, so asymptotes. What are these things? They sound weird. They sound like it's something crazy. Oh my gosh, asymptotes. And if you're not careful with it, you might say something wrong with it and be like, yeah, you want to do the right things. So do the right thing and say it right. Asymptotes. Asymptotes. So asymptotes are lines a graph comes close to but never touches. So your function will always come close to these lines, but they will never touch them. So in this graph of rational function, there's actually two asymptotes that are happening here. There's a vertical asymptote and a horizontal asymptote, and they're both found on the axes, so the x and y axis. So that's where the asymptotes are going to come from when it comes to our rational function. All right. So that's the general shape. That's what it looks like. That's the important information from it so far. Now, with these, we have asymptotes, and hopefully in the previous class you've learned these, but these asymptotes are considered our vertical and horizontal asymptotes. Vertically going up and down, horizontal going left to right. So here's how we're going to find those. For a vertical asymptote, we're going to set our denominator equal to 0 and solve for the variable. That's so hard. Oh my gosh. We're going to set the denominator equal to 0 and solve for x or variable or whatever variable is there. X, Y, Z, whatever. The only part that might get a little tricky with is when you actually have quadratic equations down there. So if that happens, then it's going to be okay. We'll still get that right. We'll still do it. All right. So the next thing is your horizontal asymptote. And this normally happens when we're dealing with fractions. You really won't have it when it comes to like what I call a single line equation. And really radicals really don't deal with asymptotes either. But yeah, it's all good. It's all good. So here, really, we're doing horizontal asymptotes with fractions. And I took an approach from what, if you're planning on going to calculus, what is used kind of there, and what kind of approach there that I learned from another teacher years ago. And I thought it was pretty cool. So here, we're going to find the variable with the highest exponent. Then we're going to divide each term by that variable. So if the highest exponent is x squared, we divide every term by x squared. If the highest exponent is x, the variable with the highest exponent is x, you divide every term by x. Then you simplify it. So if you have x squared over x squared, you simplify it down to 1. If there's any fractions left over after you have simplified, you make them go to 0. And that is considered limits, dealing with limits. As when a fraction, if the variable's in the denominator and as x approaches infinity, your fraction goes to 0. That's pretty much what we're talking about. But that's in the future. That's what we're going to talk about later on in the class. All right, but that's what we're pulling in. That's why this thing goes to 0. All right, and then we're going to simplify it completely and solve for y. Because again, the variable, the vertical asymptote is going to be your x-axis. That's going up and down, or the x value. And then your horizontal asymptote is going to be your y value. So you're going to have asymptote there that's either vertical or horizontal dealing with x or y. All right, so now let's go ahead and go to an example here where we're going to follow this up. So that's going to be on our next video.